Next topic is CSMA CD, carrier sense multiple access with collision detection. You can see four stations A, B, C, and D. Station A checks for channel idleness at time T1. At time T1, station A checks for the channel. The channel is free, it ends a frame. Here the frame is not sent completely, the frames are sent bit by bit. And at time T2 stations C checks for the channel. Now the channel is free because the bit sent by A still not reached C. And what happens is when both the frames or the bits from A and C gets closer, they gets collided. Both the frames of A and C gets collided. Now C detects collision at time T3. At time T3, C detects the collision and stops the transmission of data. And similarly, at time T4, A detects the collision and stops the transmission. Now what happens is once the collision is detected, the transfer of data is stopped. Hence the name collision detection. Once the collision is detected, it is aborted. Data transfer is aborted. And you can see this is the flow diagram of Aloha protocol. Let us compare the Aloha with CSMA CD. CSMA CD. Now it is not CSMA CD. It is I am making clear it is about pure Aloha protocol. What we studied the first topic in this module. You can see here the K is the number of attempts and TP is the maximum propagation time between the two widely separated stations, and TFR indicates the average transmission time for a frame and TP is the back of time, which is R into TP, where R is a random number. Now you can see how it works. Now you can see the station has whenever station has a frame to send, it sends a frame, and whenever it sends a frame, it waits for the round trip time. It is 2 into TP. TP is the maximum propagation time. It waits for some time, and it waits for the acknowledgement. If it gets the acknowledgement, if it is true, then it is success. Frame has reached. If it is false, that is if you won't get any acknowledgement, you go for the next attempt. Now you can see the case incremented, number of attempts is incremented. Now the second attempts, now you can go for the second attempts, and you wait for some time. TB is the back of time before you take the next chance. Before you take the next chance, you wait for some time. TB amount of time, this is the back of time. Back of time, we have formula to calculate R into TP, and again the process is repeated. And you send the only thing is you have to send the frame. Wait for the acknowledgement. Send the frame. Wait for the acknowledgement. Won't get acknowledgement, again you take the next chance till you reaches the maximum limit. The maximum limit here is taken is k max, maybe 15 attempts, depends. Now in this way this Aloha protocol works. There is no security here. You can see simply it waits. There is no many strategies as well here. There are no strategies, but now we can compare with this with CSMA CD. Only what in Aloha protocol, what we do is we send a frame and wait for the acknowledgement. We don't get acknowledgement, you increase the number of attempts till you get the maximum limit. Maximum limit is reached, need to stop sending the frame or stop taking the chance of sending a frame. Now compare this with CSMA CD. In CSMA CD we have what difference you can notice in CSMA CD and Aloha protocol is three differences between CSMA CD and this Aloha protocol. What difference you can notice is the first difference is this one. The first difference is you can apply persistence methods, P-persistent method, non-persistent method you have seen earlier. You can apply we can sense a channel before sending a frame. We can sense a channel, and what we can do is you can just on the end. Second difference is you won't send complete frame. You send frame bit by bit. You transmit and receive for the acknowledgement. Wait for the acknowledgement. It's a continuous process. If there is a if it is if there is a collision, stop abortion, stop sending the data, or stop transmitting the data. Apply one of the persistent methods and wait for the acknowledgement. Now you can see there is a collision. What happens? And the third difference is there is a jamming signal here. You can see the third difference is there is a jamming signal to alert all the remaining stations. To alert all the remaining stations that there is a collision. Don't send the frames. And also you can see rest all is similar. Rest all is similar. You can see and you can take the chance. If you cannot send, you don't need acknowledgement, then go for the next attempt. K is the number of attempts till you repeat it for 15 times. You can take 15 chances. Only difference is, what is the difference is? The first difference is applying the persistence method. Second difference is the frames are sent bit by bit, and third difference is use of a jamming signal. So what is the main difference you can notice between the Aloha and the CSMA CD? Aloha, you can see there is no persistence method, there is no jamming signal, as well as there is no here the complete frame is sent in Aloha, but in CSMA CD we send frame bit by bit. That is what is the three major differences you can notice between CSMA CD and the Aloha protocol. Coming to the last topic in this is the energy levels during transmission, idleness or collision. You can see there are three different energy levels: at zero level, normal level and abnormal level. At the zero level, you can see at zero level the channel is idle. This is zero level, the channel is idle. And at normal level, you can see here at normal level there is a frame transmission at the normal level. You can see the normal level, the frame transmission. At zero level, channel is idle. And at the abnormal levels, you can see here the abnormal levels, here is a collision. At abnormal levels there is a collision. This is what you can see, the abnormal levels, and energy is twice as the normal level in abnormal levels. Three levels: one is at zero levels, channel is idle, and at normal levels there is a frame transmission, and at abnormal levels there is a collision. Thank you.